ever pondered over how two numerical variables might be linked? Today, we unravel the mystery through scatterplots. This powerful tool, the scatterplot, is a type of diagram using Cartesian coordinates to display values for two variables simultaneously. In simple words, it's a graph that shows us how two different types of data are related. Each point on the scatterplot represents an observation. The position of each dot on the horizontal and vertical axis indicates values for an individual data point. Scatterplots are instrumental in data analysis because they can show a broad range of correlations between variables. They can help us identify trends, outliers, patterns, and much more. Whether you're trying to find out if there's a relationship between the amount of sunshine and the sale of ice cream, or you're trying to predict future trends based on past data, scatterplots are your best bet. So, buckle up as we dive into the world of scatterplots and explore their potential. Scatterplots, as the name suggests, are plots of scattered points. But what do these points represent? Well, let's delve into that. Each point on a scatterplot is like a mini-story. It represents an observation from your dataset. The position of the point along the x and y axis shows its values for the two variables you're studying. Imagine you're looking at a scatterplot of height and weight data. Each point on the plot represents a person, with their height on the x-axis and their weight on the y-axis. So a point located towards the top right of the plot would represent a taller, heavier person, while a point towards the bottom left would represent a shorter, lighter person. But scatterplots tell us more than just individual data points. They also help us understand the relationship between the two variables we're studying. This is where the concept of positive and negative relationships come in. A positive relationship means that as one variable increases, so does the other. In our height and weight example, a positive relationship would mean that taller people tend to be heavier. This would be represented on the scatterplot by the points generally trending upwards from left to right. On the other hand, a negative relationship means that as one variable increases, the other decreases. For example, if we were looking at a scatterplot of amount of exercise and body fat percentage, a negative relationship would mean that people who exercise more tend to have lower body fat. This would show up on the scatterplot as the points generally trending downwards from left to right. But remember, correlation does not imply causation. Just because two variables have a relationship on a scatterplot doesn't mean that one directly causes the other. There could be other factors at play. That's the essence of scatterplots, a simple yet powerful visual representation of relationships. They help us see patterns, trends, and outliers that might not be obvious just by looking at the raw data. Scatterplots don't just show relationships, they also indicate the direction, form, and strength of these relationships. Let's dive a bit deeper into these concepts. First, let's talk about direction. When we say direction, we're referring to whether the relationship between the two variables is positive or negative. In a positive relationship, as one variable increases, the other does too. Imagine the relationship between study time and grades. Generally, the more time you spend studying, the higher your grades. Conversely, in a negative relationship, as one variable increases, the other decreases. Think about the relationship between speed and travel time. The faster you go, the less time it takes to reach your destination. Next, we have form. The form of a relationship is about whether the relationship is linear or non-linear. A linear relationship is one where the points on the scatterplot form a straight line. This suggests a consistent relationship between the two variables. For example, every hour you study, your grades increase by a consistent amount. A non-linear relationship, on the other hand, is when the points do not form a straight line. This could mean that the relationship between the variables changes depending on their values. Maybe for the first few hours, studying more does lead to higher grades, but after a certain point, more study time doesn't translate to better grades. Finally, we come to strength. The strength of a relationship is about how closely the points on the scatterplot follow the form. In a strong relationship, the points cluster closely around the line, whether it's straight or not. A weak relationship, meanwhile, has points scattered more broadly around the line. For instance, If every time you studied an extra hour, your grade increased by a certain number of points without fail, that would be a strong relationship. But if sometimes an extra hour gave you a big boost, and other times it did nothing, that would be a weaker relationship. So, scatterplots offer a treasure trove of information, don't they? Now that we understand scatterplots, where do we see them in action? You'd be surprised, but scatterplots are everywhere, subtly guiding our decisions and shaping our understanding of the world. For instance, economists frequently use scatterplots to analyze trends and correlations in data. They might plot unemployment rates against inflation rates to study the relationship between these two critical economic indicators. If a positive correlation emerges, it could suggest that as unemployment rises, so does inflation. This is a fundamental observation that can have far-reaching implications on policymaking. In the healthcare sector, scatterplots prove invaluable in medical research. Suppose researchers are investigating the relationship between physical activity levels and heart disease. They could plot individuals' daily exercise durations against their heart disease risk scores. If a strong negative correlation appears, it indicates that as physical activity increases, heart disease risk decreases. Such insights can influence public health guidelines and personal lifestyle choices. In education, teachers can use scatterplots to understand student progress. They may plot students' hours of study against their test scores. A positive correlation might show up, suggesting that more hours of study lead to higher scores. This can help teachers tailor their teaching strategies and offer targeted support to students. So, as you can see, scatterplots are like silent detectives, unveiling hidden relationships between variables in diverse fields, from economics to healthcare and education. To summarize, scatterplots are graphical representations that help identify and describe the association between two numerical variables. They reveal the direction of the relationship, whether it's positive, where both variables increase together, or negative, where one variable decreases as the other increases. They show the form of the relationship, be it linear or non-linear, and they provide an indication of the relationship's strength, whether it's strong,